Greetings everybody. Master Palkumar Pathak. Welcome to problem solving series of LeetCode. Today we are going to solve the question 387, first unique character in a string. We will start by understanding the problem, what it is trying to say, and then move to the most optimal solution directly. Because of the complexity of the problem, it is much simpler. You will also figure out by yourself how to solve the problem after understanding it. So let's start by understanding what our problem is trying to say. So we are given an input in the form of a string which only contains lowercase letters as mentioned in the constraints below. And our task is simple. We just need to check that how many unique characters are in there in the given input string, and then return the index of the first unique character which is coming in our way. Okay, if there is only one unique character, then we just need to return the index of that. And if there are more than one unique characters, we just need to return the index of the first one coming from the starting in the given string. Okay, let's see an example. See, here you can see we are given a input in the form of LeetCode. Okay, it contains 5 characters unique: L, T, C, O, and D. Okay, and as you can see, the first unique character coming in our way is L, and its index is 0. So our output is also 0, which we need to return. So this was our complete problem. Let's move to the most optimal solution directly. Most of you would have just figured it out how to solve this. So then let's just move to the optimal solution. Okay, now let's just think how we can solve this properly. See, first of all, as you know that for checking if our we can say character is unique or not, we also need to deal with the frequency of our character which we have. Okay, now for that we obviously need to count frequencies which we are having in our input string. Now first of all, let's just do that part. Okay, that counting frequencies. Now for that, obviously we need to use a hash based structure. Best one to use here is map. Okay, because we need to store frequency like character and its frequency. So key and value, it can be easily used here. Okay, much time efficient and memory efficient also. So let's just use by storing each and every character's frequency in a map. Okay, we are going to use unordered map. Okay, which will further save much time of us. Okay, now map, and our key will be in the form of character and our value will be in the form of integer. Okay, because we are going to store the frequency. Obviously its name will be store, and inside that, now let's just iterate through our given string. Okay, we will iterate from the start character to the ending character. Okay, and during that iteration, what we'll do is we will simply write this store of s of I plus plus, which will at the end of this loop help us store the frequency of every letter in the same order, which is in which the letters are present in the string in the input. It will store in the same order the frequency of every letter in the form of key value pairs inside this store named map, unordered map. Now as we have the frequency of every letter, what we'll do is we will simply again iterate in our given input string. Okay, why? Let me just tell you. During that iteration, again we will just simply check that if the store of our current character, if the store of that is equal to 1, okay, we will just simply return our index that we are currently on, which is our simple task, that during the iteration into the complete string, if our current character's frequency in the store, if it's equal to 1, simply return the index at which we are. Okay, so also if we don't have any index, we will just simply return -1. Okay, this is our simple way that we can check by after storing. If our current character's frequency in the store is equal to 1, return that index, and if we don't have any index currently, then just return -1. Okay, this like you would have just figured out that we have completely solved this problem. Let's just run for the main test cases. Okay, I think, okay, here's a written mistake, sorry for that. It will be s.size. So let's just run for the main test cases. Yeah, it works perfectly. Let's just submit the code for the internal test cases to check if that works for them. Okay, yeah, it works. Obviously the time is much low. Okay, please, I'm really sorry for that. Okay, please forgive me because there is some network error, plus the code can be further optimized. Okay, I will mention how we can optimize that. Okay, it is taking time because, as I mentioned, there is some error in the my network, plus we can further optimize too. Okay, also obviously we are using map, so it will take some time too. So let me just mention how we can further optimize this code. So instead of using a map, a hash based structure, we can further optimize it by using an array. Okay, array, or we can say a vector. Okay, because map, obviously it is storing two things in one time, like key as well as value. But we know that we have a fixed number of positions, which is 26, because the number of letters with which we are going to deal is obviously in the range of 26, A to Z only. So what we can do is we can just simply use a fixed sized array. Okay, which where like we can store like it, because array is zeroth index, zero indexed array. So what we can do is we can just simulate that A is at the position of 0, B is at the position of 1, and similarly till 26, as you can see here, A will be at 0, B will be at 1, C will be at 2, and similarly Z will be at 26. Like here it will be 25 because 1 will be less. Okay, so uh, yeah, so this way we can keep the positions fixed for an array, and like that we can just store the frequency for every letter in this array, and after storing that we can obviously do this same thing again, like iterate through the string and check if the values, like current character's value frequency in the array is equal to 1, just return that index that we are currently on, otherwise return -1. Okay, so this part will be completely same. What will just be different is this part, that instead of map and storing in map, we will use a frequency named array. Okay, it will be like a integer array because we are going to store frequency, and let's name it as frequency. Okay, otherwise let's just name it as store, so that this can't be changed. Now, as I mentioned, the array size will be fixed 26, and for initialization we will initialize all of them as 0, because every letter's frequency is 0 at the start. Now like we were doing in the previous approach, we will just iterate through the complete string again. Okay, and during that iteration, as I mentioned, we will just increase, like according to the letter we are at on, we will just increase it, the frequency's value, by 1, so that we can store every letter's frequency in our array. So store of, again, s of I will be ++. Okay, so instead of creating a new map and storing key and value, we will just simulate in our mind, because we have fixed positions 1 to like 0 to 25 only. So we will just simulate that A is at 0, B is at 1, like that way from 0 to 25, and then we will store our frequency according to the letter. This way, at the end of this loop, like this loop, we will have the store array which will contain the frequency of every letter according to its position, -1. So this part will be, as I mentioned, it will be fixed. Like if the array that current character's value, frequency's value in store is equal to 1, return the index, otherwise return -1 at the end of the page. I think this should perfectly work. Let's check for the main test case. Okay, yeah, okay, I just forgot to write one thing here. See, as I mentioned, we are just not using the letter directly. Okay, the array is integer, plus it is 0 indexed. So if we write here like just -a, everything will be fixed perfectly, because I have mentioned in previous videos also that for converting an integer into its converting a character into its integer value, we can deal with a mathematical operation by subtracting a in the form of character, so that we can store ASCII value of that character inside array or any storage that we are going to store. So this way it can work perfectly. Let's just now run. Okay, it will now work perfectly. Okay, here also we need to write the same thing. Okay, just a second. So yeah, now it will work. So as you can see, so now for viewers of which have just not understand what I did, I just fixed one error, that is, instead of like, because our array is integer, we can't store like directly write s of I. Okay, we need to convert it into its ASCII form, or we can say like convert it into its actual place value. Like for Z it is 25, A it is 0, that way. For which we just need to subtract A from it in the form of character. which will help us to subtract ASCII values and give us the actual index that we want to deal with. Okay, this way we can perfectly solve this problem. Let's just submit it so that for the internal edge cases also. Okay, so yeah, it is optimized. You must have just figured out it was like here for a previous one, and current is like directly moved jump from this to this. Okay, this is a bit low because obviously of my network error, as I mentioned earlier. So this was our complete approach. Okay, like first one was not brute force, but it was a mid approach, and this is optimized one, the optimized approach of the previous one. So I will just like for the ones who want to check the code, you can test it by yourself by taking the both the codes will be attached in a repo, of which the link will be attached in the description of the video. You can check that. Also, if you want to check more questions like this, it is present in the LeetCode problem solving series, a playlist which I have made, and further more questions are also going to be added in the future. Also, if you like the way I explain and solve the problem, you can like the video and subscribe the channel for more tech and coding related content. If you want to connect with me personally, you can use my social connections link present in the description of the video. Thank you for staying till the end. Thank you very much.